Hi guys, so I just wanted to show you this today because one of your assignments are going to be to find the 6 trig trig ratios for these special triangles. You probably have learned about these in geometry, the 45, 45, 90. As you know, inside any triangle, right, you have 180 degrees if you add up all of the angles. So with a right triangle, this is always 90. And then for this equal isosceles triangle here, both of these angles and sides are equal, right? Because this is the 45, 45, 90, okay? This is the 30, 60, 90 triangle, which if this is 90 and one of the angles is 30, the other one is 60, right? Because that adds up to 180, okay? So they have certain rules if you're trying to find the legs and the angles where there's it's kind of like a shortcut to learning how to find that, okay? So these are really, really important, and we're going to be working them as we move forward. So it's important that you get used to them. So today, as one of your assignments is I'm going to have you find the all of the sine, cosine, tangent, cosecant, secant, cotangent for the 30, the 60, and the 45 degrees, okay? So when you're doing the 45, you obviously only have to do one, right? Here I want you to do one from a 30-degree angle and from the 60-degree angle. So opposite hypotenuse would be for the 60, or if you're on the 30, that would be opposite, that would be hypotenuse, right? Okay, this one you could use either, doesn't matter. Okay, so when you're going to be doing that, sometimes you're going to get some radicals in denominators, right? So this is just an example of how to rationalize. How to rationalize the denominator. I don't want you to ever leave a radical in the denominator. So for example, if it comes up where a radical's in the denominator, you have to rationalize it, which I know you've learned this, but in case you forgot, the way you do this, if I wanted to rationalize this denominator, I want to get this radical out of the denominator. So in order to do that, I'm going to multiply it by itself. So I'm going to multiply this by radical 2 over radical 2. Why? Because what's going to happen down here is radical 2 times radical 2. It's like having radical 2. It's like having radical 2 squared, right? Where the square and the square root cancel. Sorry, I wasn't in the screen here. Right? So radical 2 times radical 2, or you can look at it this way. Radical 2 times radical 2 is radical 4, which is just 2, right? So either way, you're getting rid of the radical, right? So I'm going to multiply this by radical 2 over radical 2, so I get 3 radical 2 in the numerator over 2. So this is the same as this. If you put this in your calculator, you get the same thing. But I don't want you to leave it like that. So make sure if that happens in your assignment, you rationalize the denominator. Okay? And then there's one other kind of problem that's going to be on your assignment. This says, if the cotangent of theta, find the cotangent of theta if the secant of theta is 5/4. So what you're going to need to do, I suggest you draw yourself a little right triangle. Okay? Now secant is the reciprocal of cosine, right? So if cosine of theta is adjacent over hypotenuse, right? Secant is going to be the reciprocal, which is hypotenuse over adjacent. Right? So draw yourself a triangle, put an angle in there. It doesn't matter where you put it as long as you follow, the right sides correctly. So if my secant is 5/4, that means my hypotenuse is 5 and my adjacent is 4. So I'm going to do, my hypotenuse is this one is 5. My adjacent is this one is 4. Now I have a triangle. Now you can find the cotangent. So I'm going to have to, what is cotangent going to be? Well, tangent, right, would be opposite over adjacent, right? So cotangent is going to be adjacent over opposite, right? So if I want the cotangent of this angle, I have adjacent over opposite. So I'm going to need this side. So what you're going to have to do is you're going to have to use the Pythagorean theorem, right? So a squared plus b squared equals c squared. Notice that this is here. This hypotenuse has to be your c. All right, so what does that give me? 16 plus b squared equals 25, right? So b squared equals 9 and b equals 3. If you notice, this is a 3, 4, 5 triangle. You might not have even had to have done the Pythagorean theorem. That's one of the famous perfect Pythagorean perfect triple triangles. Okay, so now I can find the cotangent that I was looking for. The cotangent of the angle theta is adjacent over opposite, which is 4/3. My paper's moving. Sorry. All right, let me know if you have any questions. So those kind of things are going to be on today's assignment. Have a great day.